Okay, so this is assignment 6 for SLHS 1302. For part 1, you have 5 concepts that you're going to want to define. These concepts are mean, median, mode, interquartile range, and standard deviation. These first 3 concepts are measures of central tendency, and then these 2 concepts are measures of dispersion. You can find these 3 concepts in your chapter 6 notes, and then these 2 concepts in your chapter 7 notes, both of which are under the unit 2 lectures. All right, so for part 2, we are going to be using R. So in this application of R, we're going to analyze the central tendency and dispersion of data in a given file. So in this file, we have the grades of 3 exams and 11 labs from 73 students. Each exam has 40 possible points, and each exam accounts for 25% of the final grade. The 11 labs account for the remaining 25% of the grade. So in steps 2 and 3, we're going to compute the final grade for each student, and then in steps 4 and 5, we will perform the analyses to find the characteristics of grades from the class. So you're going to want to fill in the highlighted portions to complete this assignment, and so each portion or highlighted region is worth half a point. So to begin, we're going to want to set up our directories. So if you have a PC, use this code line. Mac users use this line, and then remember to replace the X's with your username. So we will copy our code lines, open a new script, and then paste. Replace the X's with your username, and then run. All right, and then we will copy both of these code lines, and whether you're a PC user or Mac user, you can use these 2 code lines. All right. So now we can move on to step 1, where we will read in the file. So the file we are reading in is from this web address. It does have column headers, and so we are going to be assigning it to the name G. So we'll just copy this code line, paste into R, and run. So we'll see G pop up over in this global environment. All right, and then if we want to see what G looks like, you'll copy this line, paste, and run. All right, so we see our columns here, as well as information here. So this is just the output of G. All right, and so now if we want to replace the missing values that we have in our data set with 0, we would use this code line right here. So just copy this, paste into R, and run. And then if you wanted to again check what G looks like, just type in G and run. And so we now see that whereas up here we had NA for those missing values, down here we now have zeros to replace those missing values. All right, so now we want to look at the dimensions of G. So we will just take this code line right here, copy, paste, and run. And so we see we have 73 rows and 14 columns. All right, and so now if we want to see the first few lines of G, we would do head G. So we'll copy that code line, paste into R, and run. So we can see the first few lines of this code line, or of this data set. And then tail G would show us the last few lines of the data set. So run tail G, and so we see the last few lines. So with head, we were getting the first 6. With tail, we were getting the last 6. All right, so now for step 2, we are going to select variables from the input file to convert the exam scores into percentages. So we will take this code line right here to convert the exam 1 grades into percentages. So we'll just copy, paste into R, and run. And so we'll see the percentages of exam 1 show up over here in the global environment. And so what this equation here just means is that we're just taking the exam 1 grades, dividing by 40 because each exam is worth 40 points, and then multiplying it by 100 to get us that percentage. And so now if we want to check and see what the percentages of exam 1 look like, we would just type in P exam 1 and then run that. So now here we're seeing those percentages. All right, now we want to do the same thing for exam 2. So we want to fill in this highlighted region. So we would basically type what we have for exam 1, except we want it for exam 2. And so that is what you would have. So you would have the grades of exam 2 divided by the 40 points times or multiplied by 100 to get those percentages. So we'll copy that code line, paste it into R and run. So we'll see the percentages for exam 2 over in the global environment. And then we will have the same thing for exam 3. So G $exam 3 divided by 40 multiplied by 100. And so we will copy this code line, paste into R and run. And so then we see the percentages for exam 3 over in the global environment. All right. So now if we want to find the mean lab grade for each student, we will do the rows of the means. So 4 through 14, and then we'll assign it to the name lab mean. So, and this 4 through 14 is just columns 4 to 14 of each row is what we want to pull out of the data set. So we'll just copy this code line, paste into R and run. So we see lab mean pops up over in the global environment. All right, so now if we wanted to determine the final grades of the students, we would want to combine all of these exam grades with the lab means. So we'll take this code line and do that, but we first want to replace this highlighted section with our percentages for exam 2. So we would do P underscore exam 2, multiply that by 25 over 100 because it is worth 25% of our grade. So we'll copy this, paste into R, and run. And so then we see final is popping up over here in the global environment because that is what we are calculating when we are combining percentages of exam 1, 2, and 3, as well as with the lab means. Okay, so now for step 4, we are going to analyze the final scores of the class. So first, we are going to look at the mean of the final grade. So we'll take this code line right here. So we're just doing mean of final, and we're assigning it to the name F mean. So we'll copy that, paste into R, run. So we're seeing F mean over here in the global environment. And then if we wanted to see the values of F mean, we would just take F mean, put it into R and run. And then we're seeing the values. So the mean score is 78.77. All right, now we want to do the median. So we would replace this highlighted area with median of a final. So it's what we had up here with mean, except instead of mean, we're looking at median. And so we're doing the median value, we're looking for the median value of the final, and we're assigning it to the name F median. So we'll copy this code line, paste into R, and run. And so we're seeing F median pop up over here. If we want to see what the value is of F median, we would just take F median, type it into R, and run. And so here we're seeing a value of 82.38636. All right. And so then, as it says here, the median should be 82.38636. All right. And now if we want to do the mode, we're going to tabulate final and assign it to the name ftab. So run that. We're seeing ftab pop over here. And so what this function is doing is it's just creating a table containing the frequency of each score. So this just means the how many times each score occurs. And now we are able to look at the mode. So what we will do is take this code line to look at F mode, or the mode of the grades. All right, so we see F mode pop up over here. And then if we want to look at the value of F mode, we would just take F mode, put it into R, run, and we're seeing that the the most common grade which occurred was an 82 for the final grade of the students. All right, and so now we want to look at the standard deviation of the final grades. So we would just do the function SD and then final. And then we're giving it the title FSD for the standard deviation of the finals. Copy this code line, paste into R, run. We'll see FSD pop up over here. If you want to look at the value of FSD, you just take FSD, put it into R and run. So we're seeing that the standard deviation is 13.16 for the final grades. All right, and now if we want to look at the range, we're going to find the max of the final grade, so the maximum grade for the final, and then subtract that by the minimum final grade. So the highest grade minus the lowest will give us our range. So we'll copy this code line, paste into R and run. So we're seeing F range pop up over here. And then if we wanted to see the value of the range, we would do F range, put it into R and run. And so we're seeing that we have a range of 71.95 points. So the difference between the highest grade and the lowest grade would be 71.95. All right. So a second way to find the range is to use the range function. So we would just do range of final and assign it the name range. So we can do copy, paste, and run. Range pops up over here in the global environment. And then this code line, paste it into R, run. So we see F range 2 over here. So now if we want to see what the value is for F range 2, copy that, paste into R and run. And then we're seeing we're getting that same value of 71.95. All right, so now it wants us to complete this table here using the values that we found. So for the mean, we would have, if we go back to R and scroll up a little bit, we'll see that our mean is 78.77382. So we can copy that, paste into here. Our mode, if we go back, is 82. So just copy 82, paste into R. Our standard deviation, go to here. We see it's 13.16, copy that, paste into our assignment document. And then the range we have, can use either one of these. So the 71.95, so copy, paste into our assignment document. All right. So now that we have those values, we can move on to step 5, where we will plot graphical results. So we're going to want to create space for 2 plots in one column. So we'll take this code line right here, paste into R, and then run it. And so this is just making space so that in our plotting area, we can have the 2 rows and 1 column. All right, so now we're going to create a histogram. So we're going to specify what data we want to plot. So in this case, we're using final. So we will replace this highlighted region with final. And then we can take this code line, copy, and paste into R. And so what it's doing is it's creating a histogram. It's giving us a title, histogram for final grades, a x-axis label of scores, and a y-axis label of number of students. All right, and so we can add a frame for this plot by using the blocks function. So type that in and then run it. So we see that there is a box now around our histogram. All right, and so our next step is to add lines to indicate where our mean, median, and mode are. So we'll take these 3 code lines right here. First one for mean, second one for median, and the third one for mode. We will run them. And we should see 3 lines pop up in here. So we see we have a red line for mean, an orange line for median, and a blue line for mode. Okay. And then if we wanted to add a legend to indicate what these 3 different lines mean, we'd copy that code line, run it. So we'll see a legend pop up. And so the legend is just telling us what the red line indicates, what the orange line indicates, and what the blue line indicates. Okay. so now we're going to want to plot a box plot below our histogram. So we'll take this code line right here for the box plot, paste it and run it. So the box plot once again is for final. Horizontal equals true, so we want the box plot to be running in a horizontal fashion, and the color green is to indicate our 25th through 75th quartile range is. Okay, and then if we wanted to add a title, we would just take this code line to add a title, and I believe we are also adding a x-axis label, so we will run this. So we're seeing our title box plot for final grades and our x-axis label of scores. All right, and so now you're going to want to save this image, run these two code lines. All right, and our image is saved. And then also, just an important reminder, it says for the box plotting a box plot, we have this bolded area right here, and it says these circles are where the possible outliers are. So we look in our box plot, we see a number of circles, and those are just to indicate possible outliers in our distribution. All right, and so now we have a space to insert a graph. So you can do this however you prefer. And so we'll put our plots in our assignment document. All right, so you should have something that looks like this. All right, and we're going to use that to answer the following questions. So it says, is the histogram from step 5.2 positively or negatively skewed? So a positive skewed histogram, we would see a lot of the distribution down here. Negatively skewed histogram, we would see the distribution down here. We see that we have the distribution up here, so we have a negatively skewed histogram. So we just type in negatively skewed. Whereas a normal distribution, we would see our values in the center right here. So once again, just to reiterate, positive skewed would be down here, negative up here. All right, and now it says interpret negative skew by answering the following two questions. So for question A, it says if the distribution of grades from a class is negatively skewed, in terms of distribution shape, is the longer tail on the left side or the right side of this distribution? So we have a negative skewed distribution, so our tail is to the left side. So with a negative skewed distribution, we would have a tail to the left side. With a positive skewed distribution, we would have a tail to the right side. So we have a left side tail. So you can just type in left to indicate that the tail is on the left side of our distribution. All right, so question B says, if the distribution of grades from a class is negatively skewed, are there more people with higher grades than people with lower grades, or are there more people with lower grades? So let's take a look. So we see most of the individuals are up here where they have higher scores. If we had a positive distribution, we would see lower scores. So with our negative skewed histogram, we would say that there are more people with higher grades. Okay, and then for our final question, it says, read the box plot you generate from step 5.3 and the instructions below that code line. How many outliers were there in this box plot? So if we go back to step 5.3 and we look at that instruction, it says these circles are where the possible outliers are. So since we want to look at outliers and we want to figure out how many outliers were there in this box plot, we would want to count these circles. So we see clearly 1, 2, 3, 4, 5, 6, 7 outliers. But if you notice, these two right here are quite a bit darker than the others, which just indicates that there are more, there's like a layering of outliers here. So we actually have 1, 2, 3, 4, 5, 6, 7, 8, 9 outliers. So you just type in 9 outliers. And if we were to go back into our plot and extend it a bit, we might be able to clearly see those 9 outliers. And so yeah, you see here that there's a bit more of a distinguishment between these two and these two. All right, so just to go through what you need for this assignment, you'll want to have your definitions for these 5 concepts. As I said, you can find them under the Unit 2 section. These 3 concepts will be in the Chapter 6 notes, and these 2 will be in the Chapter 7 notes. You will want to have a number of highlighted portions filled out. So you want to have this filled out for exam 2, this filled out for exam 3. You will want to have this filled out for exam 2 in this code line for the final grades. You will want to have median final filled out for the F median code line. You'll want to have SD final for the final standard deviation code line. All right. You'll want to have these highlighted regions in this table filled out for mean, mode, standard deviation, and range. You want to have final typed in here in this code line for the histogram. You will want to have this graph inserted, so the histogram box plots. And then you want to have your answer for these 4 questions. So question 1, negatively skewed. Question A, left. Question B, there are more people with higher grades. And then question 3, 9 outliers. And that is all you will need for this assignment.